Welcome back, everyone. So today we're going to continue our study in statistics. In the last lesson, we looked at a visual representation called a box plot or a box and whisker plot, and we saw what kind of information we can pull from that box and whisker plot, depending on whether it was a measure of center or a measure of spread. And today what we're going to do is we're going to look at another visual representation that we can use to look at a set of data that we're given, and that's called a dot plot. And what a dot plot is it's just a number line, and we're going to place on this number line either dots or X's, depending on the frequency of the value in our data set. Okay, and so let's take a look at an example so that we can see actually how to construct this dot plot. All right, and so we have an example here where we have 12 employees at a small company and they make the following annual salaries in thousands of dollars: $25,000, $30,000, $35,000, $35,000, and etc. Okay, and what we want to do is we want to construct this dot plot using the following number line. All right, so I've incremented the number line in increments of 10. So going from 20 to 30, 40, and you want to always label your number line based on what you're categorizing. Okay, and so let's grab, what I want to do is I want to begin to place X's wherever we have values. So for example, our first value is 25,000 or 25 in this case. So we want to place an X above the 25. Okay, and we want to do the same for the remaining values. So I'm just going to place X's, and wherever you have multiple values that are the same. For example, in this case, we have 3 values that are 35. You place the X's vertically on top of each other. Okay, and the same thing for 40. Okay, and so we've created our dot plot. Now, looking at this dot plot, there are certain things that certain information that you can pull from this dot plot. The one thing, one of the things that we can pull from this dot plot is the median. We can also find the mean value based on, and we do it the same way that we find it originally when we found it, by adding up the sum of the values and then dividing by the total number of values that we have. You find the average. To find the median, instead of using our list and chopping off the numbers from each end, what we're going to do, as I showed you in the previous lesson, is you look at the total number of values that you have and you divide that by 2. So in this case, we have 3, 6, 9, 12 values. So if we divide that by 2, we get the 6th value. And remember, whenever you have an even number of values, you take the average of the 6th and the 7th value. So you take the, so in this case, our 6th value, we're going to count on our dot plot. So we have 1, 2, 3, 4, 5, 6. Our 6th value lies here, and then our 7th value. So we're actually going to take the average of these 2 values, which in this case, both values are 40. So we know that our median is going to be 40. Okay. Another thing that we can calculate is the median of the lower set of our data, which is also our quartile 1 value. In this case, our quartile 1 value is going to be 35. And then we can also calculate the median of the upper half of our values, which is our quartile 3 value. And in this case, it's going to be 45. Okay, and so from these values that we've calculated, we can tell certain things about our data set. That is, for example, because our median is 40, we know that on average, the employees in this company make $40,000 a year on average. Okay, we can also tell that the employees that rank in the lower half of our data set, they make on yearly $35,000 annually. And the employees that rank in our upper half of our data set usually make around $45,000 annually. So they have a little higher salary than those that are in the median and those that are in our first quartile or our lower half of our data. All right, and let's look at an example where we're going to add in the manager's salary. And so the owner or the manager makes $150,000. So he makes a lot more than his employees, right? So now we want to construct a dot plot for this set of values where we've added in the manager's salary. Okay, and so we can see that here I've reconstructed my number line so that I can add in the $150,000 value. So my increments now are in increments of 20. But I'm going to construct the same dot plot. So 25 would be here. So this is 30, 25. So we're going to have 25 here. We're going to place an X. 30 would be in the middle. 35 would be here. We're going to have 3 35s. 40. We're going to have 45. So an X here. 50 is in the middle. We have 160, and then we have a value of 150, which is going to be over here. Okay, so we've constructed the dot plot, adding in our value of 150. Now, if I were to calculate the values of our median, our first quartile, and our third quartile here, what I would get is that the median is still going to be 40. For quartile 1, we're going to still have the value of 35, but now that we've added our value of 150, the value of our quartile 3 is going to change because we've added in this value of 150,000. And so now our quartile 3 value is going to be 47.5. Okay, so once we've added in the owner's salary, that is going to make the upper half of our data set, those employees in the upper half, their average salary is going to now jump to $47,500. So it increased their salary range. Okay, and the next thing that I want you to notice is that when we constructed this dot plot, notice that this value of 150 lies way out here from the rest of our data set. And that's called an outlier. So anytime that you have a value that's in your data set that's far off from the range of where the majority of your data set is, that's called an outlier. In this case, it's to the far right of our data. Sometimes it could be to the far left of your data. Okay, it all depends on what your data set is. Now, in the case that you have an outlier, sometimes points or values in your data set will look like an outlier, but they are not necessarily an outlier. So we can figure out from the data that we can pull from our dot plot whether or not a point is an outlier. And we do that by if your outlier or if that point seems far to the left, then you can figure that out by using your first quartile value. And what you're going to do is you're going to take the first quartile value and you're going to subtract from that 1.5 times the interquartile value. So Q1 minus 1.5 times the interquartile value. Now, if your point lies to the right or to the far right of your data set, then you're going to use your third quartile value, which is Q3, and you're going to add 1.5 times the interquartile value range value to your third quartile value. So in this case, if we wanted to check, which we can see that it clearly is an outlier, but if we wanted to check whether or not this point 150 or value 150 was an outlier, then we would use the second equation, and we would plug in, and so we get that Q3 is 47.5 plus 1.5 times our IQR. But remember, our IQR, we take the value of Q sub 3 minus the value of Q sub 1, or our third quartile value minus the first quartile value, and we get a value of 12.5. So when we calculate this, we see that X needs to be greater than 66.25 in order to be an outlier. And in this case, 150 is definitely greater than 66.25. Okay, now comparing our data set from the first, or our dot plot, comparing this dot plot to the dot plot of when we added in the owner's salary, there are some things that we can see. So if we, here I filled in our values for comparison of the employees versus the manager or the owner. Okay, now as you can see, when we added in that value of 150, our mean value increased. Our range definitely increased because we know that 150 is going to increase our range value by a lot. Our interquartile range value increased, and our standard deviation increased because now we have that this outlier value is really far away from the mean value of our data set. But the median stayed the same. So the median value stayed the same. And the median value stayed the same because we've added in, originally we had 12 values. When we took the median of that, it was 40. Now we have 13 values, but in this case, when we take the median again of these 13 values, we still land up in the 40 area, or the cluster of 40 in our data set. So that did not change our median just by adding that outlier. Okay, and so that's one of the things that I want you to realize is that when you add an outlier, either your values of your mean, your range, your interquartile range, and your standard deviation are going to increase if the outlier is to the right, or it's going to decrease if the outlier is to the left, but your median will never change. Okay, and finally, we have a way of talking about the distribution of our data when we deal with dot plots. So when we deal with dot plots, depending on how our dot plot is situated and how our data values are distributed, we can say that the dot plots are one of three things. It's going to be skewed to the left, it's going to be symmetric, or it's going to be skewed to the right. Now, of course, symmetric is that your data values are evenly distributed along your number line. If it's skewed to the left, and this is what I want you to be careful with, if it's skewed to the left, that means that the majority of your data values are going to be to the right on your number line. So it's the opposite of what it actually is. If it's skewed to the left, the majority of your data values are going to be to the right. If it's skewed to the right, the majority of your data values are going to be to the left. Okay, and so let's look at a quick example. We have a data table here of the number of miles run by members of two track teams, Team A and Team B. And I've already constructed the dot plots for you. Now, looking at Team A, we can see that Team A's data values are, or this dot plot for Team A is symmetric. It's evenly distributed along our number line. For Team B, our dot plot is going to be skewed to the left because most of our data values are on the right of our number line. Now, there are some things that we can compare about these two. In Team A, because our dot plot is symmetric, we expect that our median value is going to be in this cluster of points in the middle. So we expect it to be somewhere around 4, or somewhere between 4 and 4.5. For Team B, our median value is going to be around the cluster of points to the right. So it's going to be somewhere between 5 and 5.5, or somewhere close to 5.5, and we expect that. So when you actually do the calculations for these, we get a mean, for Team A, we get a mean of 4.25, and we get a median of the same thing, 4.25. And with it being symmetric, you would expect these two values to be exactly the same. Now with Team B, because it's skewed to the left, our mean, in this case when we calculate, is going to be 4.98. and our median is going to be 5. Okay, and so as we can see, in the case where it's skewed to the left, our two values, our mean and our central values, are not going to be the same. They're pretty much close together, but they're not going to be exact because our data is shifted and it's distributed unevenly along our number line. Okay, so in these cases, what I want you to think about as we're looking at these different visual representations of how we can categorize data, what I want you to think about tonight is what is the difference and what are some similarities between looking at data on a dot plot versus a box and whisker plot. There are some similarities and there are some differences, and that's what I want you to think about as you look at these two, now that we've introduced dot plots into our statistics study. Okay, and that is the end of today's lesson.